Good evening all of you. Today we are going to see S parameters by solving a simple problem. So the question is, this is a two-port network, port 1 and port 2. For this network we have to find S11, S22, S12 and S21. Okay. Now the characteristic impedance Z0 is equal to ZL load impedance, which is equal to 50 ohms. This we are assuming, or generally we can connect this 50 ohms. Okay. Now to find out S11. So what you do is you connect 50 ohms here. Okay. From here we are finding out Z1, that is impedance viewed from port terminal 1. Okay. Now S11 is nothing but gamma 1. This gamma 1 is nothing but reflection coefficient. Which is equal to Z1 minus Z0 by Z1 plus Z0. Now what is Z1? Z1 is viewed from this terminal. So these two are in series. So this will give you 100 ohms minus Z0. This is Z0 characteristic impedance, which is equal to load impedance. This is 50 by Z1 plus Z0. So Z1 is, we know, 100 plus 50. So this will give you 50 by 150, which is equal to 1 by 3. Now this 1 by 3 is equal to 0.33. 0.33 angle 0. Now if you want to get the answer in decibels, what you do is 20 log 0.33. So if you take 20 log 0.33, you will get the answer as is equal to minus 9.551 decibels. Angle is 0 degree. So now we have found out S11. Okay. Next we have to find out S22. S22. So to find out S22, what you have to do is, from here you are viewing Z2 at port 2. This is Z2. Okay. And port 1 terminal is terminated with Z0. That is, this is 50 ohms. Z0, which is equal to ZL. So for the formula for this is Z2 minus Z0 divided by Z2 plus Z0. So we are viewing from this point. So Z2 is 50 plus 50, which is 100, minus Z0. Z0 is 50. Z2 plus Z0, 100 plus 50. So this will give you 50 by 150, which is 1 by 3, which is equal to 0.333 angle 0. If you want the answer in decibels, take 20 log 0.333. You will get minus 9.551 dB angle 0. You will get the same answer. Why? Because the circuit, the two-port network is symmetric. Either if you view from this side or that side, nothing is going to change. It is symmetric, so you will get the answer same. So S22 is equal to gamma 2. S22 parameter, gamma 2 is the reflection coefficient, which is given by Z2 minus Z0 divided by Z2 plus Z0, and we got the answer. So the next part of the question will be next parameter. We have to find the next parameter. 1. If I say S21, 2 is the output and 1 is the input, output by input. So S21 is equal to V out divided by V1 plus. Okay, now how to connect the circuit? So the output is received at port 2 and the input port is excited with, this is Z0 which is equal to 50 ohms, and you have a source which is 2V1 plus, and this terminal, output terminal, is terminated with characteristic impedance Z0 which is equal to 50 ohms. Now you may ask why we are putting 2V1 plus. It is just for convenience to solve the problem we are doing like that. Because if I say this voltage is 12, I can write 12 as 2 into 6. So that's the visualization of this 2V1 plus. Okay. Now plus means it's the forward power into the two-port network. If I put minus means it is the reflected power. Okay. So now we have to find out S21, which is V0 by V1 plus this, because 2 is the output and 1 at the terminal 2, port 2 we are taking the output, and at the input we are feeding in the energy into the system, two-port system. So for this what we have to do is, first we will find out the current flowing in the circuit. Now what is I? I is equal to input voltage, which is 2V1 plus divided by, now if you see all the impedances are in series, this is also 50. So 50, 50, 50, it is 150. Okay. Now I want V2. V2 is nothing but the voltage across this 50 or load. Okay. So V2 or V output all are same. V2 or V out all are same. V out. Now if you want V out, output voltage is equal to current into Z0. Current, because all these three components are in series, the current is same, current is not going to change. So what is I? Just now we found out 2V1 plus by 150, this is current, multiplied by Z0, Z0 is 50. Now 50 into 2 it is 100, you bring this Vn plus this side, so V out by V1 plus is equal to 2 into 50 is 100, okay, 2 into 50 by 150, so this is 3, 2 by 3. So V out by V1 plus 2 by 3, if 2 by 3 the value is 0.667 angle 0 degree, or if you want the answer in decibels, it is minus 3.517 dB angle 0 degree. Okay. So now we got the S21 value, which is 0.667 angle 0 degree, or in terms of decibels, this is going to be minus 3.517 dB angle 0 degree. Okay. Next we have to find out S12. Next step is S12. So this is going to be 1, 2. So S12 means what? At port 1 you are going to receive the output, and port 2 is the input where we are going to give. So for this will be the connection? Input is given at port 2. So this we have to change. This also we have to change. So at the input is given in port 2. This is 50 ohms Z0. Then we are connecting source, voltage source, which is 2V2 plus, and we are receiving the output at port 1. So we have a load, that is 50 ohms. Okay, so this is the scenario for S12. Now the current is driven like this. Here one thing you must note down, V2 plus means the current is incident or power is incident to the two-port network. If I put minus means it is getting the reflected back signal from the two-port source. That's the meaning. So we will solve for this. So now we have to find the current I. Now what is I? I is equal to V by R, 2V2 plus divided by 50 plus 50 plus 50, all are in series, so this is 150. Now I want the voltage at here, these 2 points, V1. This point and this point, that is voltage at port 1. This is nothing but this is the load voltage, okay. So if I want V1, the current multiplied by 50. So V1 is equal to the current flowing through this load I into 50. But we know the value for I, which is 2V2 plus by 150 into 50. So this will give you 2 by 3 V2 plus. Now what you do is bring this V2 plus this side. So this will give you V1 by V2 plus is equal to 2 by 3. So this I can write it as 2 by 3, which is equal to 0.667 angle 0 degree, or if you want in decibels, you take 20 log 0.667, that will give you the same answer, minus 3.517 dB angle 0. Okay. This is how you have to solve. You have to find the S parameters, scattering parameters, that is S11, S12, S21 and S22. Hope you have understood how to solve a simple two-port network, how to find out the S parameters. This is a simple circuit, but the procedure is same. You can find out easily. When you want to connect a source, see that it is 2V1 plus, and in series you connect a characteristic impedance Z0, usually it is 50, and the load is terminated with Z0, which is 50. This is the general procedure. If you give the source at the port 2 side, port 1 is low. If you connect load, it is equal to the characteristic impedance 50 ohms, and here a voltage source 2V2 plus indicates your insert, the energy is towards the port, in this case port 2, and in series with the characteristic impedance Z0. Thanks for watching this video.